Hey guys, welcome. This is the Module 5 quiz review. I strongly recommend that you rewatch a couple parts of this video, including things like question number 3, question numbers maybe 7 or 8. Those, in my opinion, seem to be problems where you can find yourself struggling a little bit or maybe running into some issues. So we'll talk about it in detail when we get there. But we'll start with number 1. Number 1, the pressure in a car tire is given by the equation P of X equals 34 minus X, where P is the pressure in PSI, X is the number of months since the tire was filled. Describe what this function represents, okay? So let's zoom in really, really close to this function, okay? Now, remember, P of X, P, this represents the pressure in the tire, right? Pressure in PSI. X represents number of months. Apologize about that. X represents the number of months since the tire was filled. So let's create just a little bit of a table here, just to kind of illustrate my point. You don't necessarily have to do this on the quiz, but it might help you if you want to sort of see what's going on. Okay, let's start with month 0, right? Month 0, remember X is number of months, right? So when I put X here, I'm talking about months, right? Month 0, right? This would be 34 minus 0. Well, 34 minus 0 is equal to 34, meaning that the pressure is 34. So this indicates to us that at month 0, which is just the beginning, right, we have 34 psi. That's at the start. Now let's think about what if 1 month goes by, right? Well, then it's 34 minus 1, because remember, X represents month, so 1 month would be plugging in 1 there. 34 minus 1 happens to equal 33. So that means 1 month goes by, the tire pressure is now 33. Well, try this again. What if it was 2 months that go by, right? 2 months go by. 34 minus 2 now. 34 minus 2 happens to equal 32. Okay, 2 months, 32. So you kind of get a little bit of a pattern here. You kind of get an idea of what's going on, right? As we increase 1 extra month, as another month passes, right, we are losing 1 pound of pressure, 1 psi. Now, since we identified what's clearly going on in this situation, now let's try to read these answer choices and identify which one describes what's going on. So, answer choice A says the initial tire pressure is 1 psi and it increases by 34 psi each month. There's a lot of things wrong with this. First off, initial pressure is 1. We've already established a long time ago the initial pressure was 34. Definitely not 1. Another thing that's kind of a red flag is it increases. Well, we can see a minus sign in this problem, so why would anything increase if there's a minus sign? So these are both red flags, right? It's definitely not answer choice A. Looking at answer choice B, again, it says 1 psi was the initial tire pressure. Again, we've already established that 34 was the initial tire pressure. We started with 34 at the beginning of our month. It does go down. This is true. You see the minus sign. That's a good sign. But the fact that it did not start with 1 psi, right? It starts with 34 psi. That's a problem. So that's why that one is going to be wrong. C, the initial tire pressure is 34, which is true. That's true. Initial tire pressure was 34. And it goes down by 1 psi each month. This looks promising, right? That's exactly what we saw on our table, right? We started at 34, and then we were going down 1 every month. So that's pretty good. It's pretty good. I'm gonna put a little star next to that. That's probably the answer. Let's just double check the answer choice D, see if it's any better. The initial tire pressure was 34. Again, that is correct. And it increases by 1 psi each month. Now, that's wrong. We noticed these numbers dropping, right? Because we're subtracting. Subtracting, the word increases does not correlate with the subtraction sign. So that's incorrect. It would not be increasing. So our correct answer choice going back here is answer choice C, okay? And don't forget, you've got your answer sheet over here on the right-hand side. So make sure you write your answer in over there, okay? All right, now number 2. An air conditioning repair service costs $75 per hour plus a flat fee trip charge of $25. That's a lot of money per hour, just by the way. If the situation can be represented by the function r of h equals 75h plus 75, what do the variables represent and which is the dependent variable? All right, so we really want to establish what each variable here represents. Okay, so we have to note here that R of H is going to be our end up cost, our total cost at the final end, right? The cost or the charges that we have to pay. The H here, because remember it's $75 per hour, and this is 75 times H. This is a strong indication that H represents hours. Okay, so establishing that is good before we even get started in the problem. Understanding that R of H is going to represent the cost, and H is going to represent the hours. Now let's look at our answer choices and see which one makes the most sense. The repair time H depends on the repair charges R in hours. Well, the repair time H depends on the repair charges R in hours. They have something right here. They know that H is time and the charges is R. They know that. But what's wrong about this is it's saying that the time depends on the charges. And that's just not right, right? The time's not going to depend on the charge. Time is going to be time. It should be the other way around, right? Shouldn't it? The charges, the amount that we're going to have to pay at the end is going to depend on the hours that they've worked, right? The charges we pay at the end will depend on the hours that they worked. So this is incorrect because it's backwards from how it should be. It says time depends on charges. That's not the way this works. B is wrong for a lot of reasons here. So the repair charges H. Well, repair charges H. That's weird because H represents time, right? H represents hours, not the charges. Charges, think of charges. When you see charges, let's think of cost, okay? The repair cost, H, depends on the repair time, R. R, this is backwards, right? H is time, and R should be cost or charges. So this is kind of close in a sense, but it's backwards from these letters. These letters are all wrong. Time is supposed to be H, so that should be an H over there, and then this one should have been an R. So that's incorrect. C, the repair charges R, so that's correct. Charges is R, repair cost is R. Again, if you think charges, think of cost. R depends on the repair time H. Now this makes a lot of sense. The cost, which is established by the variable R, is going to depend on the repair time H in hours. So the amount of money we pay will depend on the number of hours that was worked. In a sense, the more hours that's worked, then the more money we pay. Or the fewer hours that's worked, the less money we pay. This is exactly what this is claiming. C looks like a good answer choice. Let's just double check, make sure. Let's see what's wrong with answer choice D. Repair time R, well, we've already got it wrong, right? Repair time is supposed to be the H because H is hours, hours is time. So we've already got that one backwards. Depends on the repair time. Oh, it says repair time and repair time. Well, that's wrong on a lot of different levels there. So it doubled up on repair time. So repair time depends on the repair time. That makes no sense at all. Definitely not answer choice D. So sometimes just reading it and thinking about it, you don't have to know a whole lot of math. You just have to be able to use a little bit of your common sense. So yeah, it gets confusing because it all seems very similar. But take your time, read each question carefully, and you should be able to find the answer. Now let's do number 3. Number 3 is definitely going to be probably the most work you're going to have to do on this test. So let's discuss. We need to graph this function for these domain values. Now, here's what we need to do first, okay? What we need to do first, and you're going to have to make sure you do this on tomorrow's test, so please study this. Please go back and retry this problem again and again. First, you need to get your equation into y equals mx plus b form, also known as slope-intercept form. What I mean by this is simply get the y by itself, okay? Get the y by itself. So look at our equation, right? Let me copy this down. We have negative 2x plus 4y, so negative 2x plus 4y equals 4. Yes, okay. So there's a two-step process in order to get this y by itself. So step 1, and again, do this on tomorrow's quiz, okay? Step 1, is move the x term. Right? So let me tell you what I mean by that. Now, we have our goal here is to get the y by itself, right? So let me identify here. This is where the y is, right? Right there. It's on the left side of the equal sign, the left side of that bar. So all this other stuff I need to get rid of. I need to get rid of the negative 2x. I need to get rid of the 4, right? I need to get rid of all of this. And the first thing I'm going to get rid of is that x term. Did I just delete part of the thing? Hold on, let me go back. Was it a plus 2x? It was. Okay, so it had that, or plus 4y. There we go. All right, so that's what I'm doing. I'm going to move this x term, this negative 2x. I'm going to get rid of this first. Now, since this one is a negative 2x, to move it or to cancel it out, I would have to do the opposite of a minus 2x, which is adding 2x. So adding 2x, right? What does this do? Negative 2x plus 2x is 0, right? So essentially it cancels out, goes away. So the only thing on the left side is 4y. The problem is I have to do this on both sides. So see how I added 2x to this side? I have to add 2x to here as well. Got to add to both sides because I got to keep the equation balanced on both sides. And this is what I mean by moving it, because now we're going to have that x term be on the right side of the equation instead of the left, like where it started. So here I've got 4 plus 2x on this side. You cannot combine these terms because they are not like terms, so you have to keep them separate. But what I like to do is I like to write the x term first. So since it's a positive 2x, I'll write a plus 2x, a positive 2x. I'm going to write a positive 2x. And then since the 4 was positive, I'm going to write it as plus 4. If either of these was negative, I would have put a minus sign in front of it. So if it was a minus 2x, then I would have done, if it was a minus 2x, I would have done a minus 2x there. If it was a negative 4, then I would have put a minus 4 here. Okay, just food for thought. But it wasn't like that. They're both positive, so positive 2x, a plus 4, and we're good. Now that's step 1. Move the x term. It's very simple. I know it was a long explanation, but it's really just adding the 2x to the other side. Okay. Step 2 is divide. It's very important you remember this word. Okay, divide the number from y. So the number that's next to y, the only other thing we need to move is this 4. This 4, because it's attached to y, means it's being multiplied with y. So this is the reason why we divide. Even though it's a positive 4, you can't subtract 4 here. That's not going to cancel it out. Because it's attached to y, the only way to get rid of it is to divide by 4. That's the way you get rid of it. So we have to divide by 4, and that would cancel it out, and it would go away, and the only thing that would be left is y, which is what I want. But similarly to that first step, I have to divide by 4 on the other side as well. Now, the thing is, it has to be every term. Every term has to be divided by 4. Okay, so our answer results in 2 over 4x plus 4 over 4. Now, when we simplify this, 2 over 4 can be reduced to just 1/2. X is still there, and then 4 divided by 4 becomes 1. So here's our equation. 1/2 x plus 1. Just want to make sure. Yes, okay. Now, that's very, very useful to us. Okay, this is the equation that we need. This is going to help us a lot. But we're not nearly done with the problem yet. We still have to graph our problem. This is just the first part of it. We need this equation so that we can graph it. Now what we're going to do is we're going to create a table of values, x and y. Okay, now the x numbers are given to us already. They're from this domain, right? -8, -4, 0, 4, 8. Those are the x values that we are told to plug in. So -8, -4, 0, 4, 8. So now we can use the function that we just got and plug in these numbers for the x value and evaluate and see what the y value is. So when I do that, remember our equation 1/2 x plus 1. All right, so let's plug in -8, right? So we'll have 1/2 times -8 plus 1. And if you want to use 0.5 instead of 1/2, that's fine. 0.5, that's fine. Essentially, think of this as half of 8. 0.5 times -8, half of 8. This is just, half of 8 is 4, and since it's a -8, this would be -4. So you can do it in your head or you can use a calculator. Half of 8 is 4, and it's negative 4 in this one. Don't forget the plus 1 though at the end. Negative 4 plus 1 happens to be negative 3. So there's your y value for the first point. Now, let's plug in negative 4. So 0.5 or 1/2 times negative 4 plus 1. So again, think of this as half of negative 4. So half of 4 is 2, and since it's a negative, this means it's negative 2. And then don't forget the plus 1 at the end. Negative 2 plus 1 is negative 1. Okay, so there's that one. Now plug in 0. So 1.5 times 0, or essentially half of 0. We should know this plus 1. We should know this 0.5 times 0. That is 0. Then, of course, 0 plus 1 is 1. Now, you might already start to notice a pattern here. All these numbers are increasing by 2. From negative 3 to negative 1, that was plus 2. From negative 1 to positive 1, that was plus 2. So if this continues, the next number would be 3, because 1 plus 2 would be 3. And the number after that should be 5, because 3 plus 2 is 5. So all of these are plus 2. But let me just double check. Let me just prove that it should be 3 and it should be 5. So when I plug in 4, right, I'm plugging in 4 for this value of x now. I'm doing half of 4. Well, half of 4 is 2, and it's positive now. 2 plus 1 is 3, and that's what I put there. So see, I predicted it correctly. And we got one more to double check. So 0.5 times 8. We're plugging in 8, because that's this x value, plus 1. So it's half of 8. Half of 8 is 4. It is positive again here. And then don't forget the plus 1. Oops. 4 plus 1 makes 5. So yes, that was a good prediction. So we have our table of values. We now know the points that we need to put on the graph. All that's left to do is to put these points on our graph. So we go to our graph. Let me rewrite the points. We have negative 8, negative 3, negative 4, negative 1, 0, 1, 4, 3, and 8, 5. So let's put these on the graph. So negative 8, negative 3. So 1, 2, 3, 4, 5, 6, 7, 8. And negative 3, that's going to be here. So negative 8, go 8 spaces this way, and then 3 spaces down. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that works. Okay. So then the next one is negative 4, negative 1. So we go over negative 4, then down 1. So that's here. So again, that's going negative 4 this way, and then just down 1. We get this point here. The next point would be 0, 1. That's a pretty easy point. That's going to be right there. Then 4, 3. So we're going to go over 4 and then up 3. So that's going to put us right here. And then the last one, 8, 5. So go over 8 and then up 5. And that's going to put us 5, 6, 7, 8 right there. And so those are our points. That is our final answer. Don't do a line here. There's no line. No need to draw a line. Simply because we are only asked to graph these x values. It told us which ones to graph, so we graphed them. That's all it wants. Just put those 5 points on there, and you're all set. You're all good. So number 3, definitely a challenging problem. It kind of is a multi-step problem, because the first thing we did was simplify the equation to something that I can use to graph. Then I used that equation, and I plugged in all my numbers, right, to create my table. And then once I've created my table, I went to my graph. So it's kind of like a 3-step process. But it can certainly be a lot of work. But nothing that you guys can't do. Just remember the process. Like I said, go back, rewatch it, do it again and again until you got it. Okay. All right. All right, here we go. That's just erasing that. All right, now number 4. Number 4 and number 5 are pretty easy problems compared to number 3. Number 4 says use the intercepts to graph the line described by the equation. Okay, so intercepts are easy to find. So our equation is negative 2x plus 4y equals negative 8. Now, if we want to find the x-intercept, what we're going to do is essentially throw out the y term, right? We want to find the x-intercept, then we're going to solve for x. This means, plugging in 0 for y. Essentially, you can just throw out the y term, but what technically is happening is negative 2x plus 4 times 0. Again, you're putting the 0 in for the y equals negative 8. Well, again, that just gets rid of the y term, as I mentioned. So when I'm solving for the x-intercept, essentially I'm solving the equation negative 2x equals -8. So pretty simple to solve, just a one-step problem. So I divide by -2, and I end up with x equal to a +4. So our x-intercept here is +4. Let me put that over here. X equals a +4. The y-intercept, so is sort of the same but opposite, right? The y-intercept is getting rid of the x term, right? Putting 0 in for x. So the y-intercept, right, is getting rid of the x equals 0. So getting rid of the x would look like this, -2 times 0, because that's where the x term was, plus 4y equals -8. Of course, being multiplied by 0 gets rid of it. So again, remember, essentially all you're doing, you're getting rid of the x term, you're solving the rest of the equation. The equation is now just simply 4y equals -8. So divide by 4, we have y is equal to -8 divided by 4, which is -2. So our y-intercept is -2. All right, so just again to recap what we did, quick summary, quick synopsis, is if I want to find the x-intercept, right, then I get rid of the y term and I solve the equation -2x equals -8. So just pretending the y term doesn't exist. If I want to find the y-intercept, then I get rid of the x term and just solve the equation 4y equals -8. And I get my two results. This one was x equals 4. This one was, y equals -2. Now we just need a graph. So it's pretty simple. So our x-axis is the one that goes left and right, and the y-axis is the one that goes up and down through the middle. So x at 4, so we're going to look at our graph. We're going to go to 4 on the x-axis, which is right here. Okay, so you're just counting over 4 spaces. And then the y-axis, which is this one, we're going to go down to -2, which would be right here, because remember 0, 0 is in the middle. So I plot those 2 points and then just try to sketch a line through those points the best you can, and you are done. Okay, so pretty simple. It tells you, exactly what to do. Put a 4 on the x-axis, put a point at -2 on the y-axis, and then just connect the dots. Okay, but draw a line through them. Don't just connect them. Don't just do like this. Okay, draw a line through the points. Okay. Number 5 is exactly the same problem, basically. So we shouldn't have any problem with that. Let's try it, though. So number 5, we have the equation 7x minus 3y equals 21. So again, same idea. Graph it using the x and y intercepts. Okay. So remember, if I want to find the x-intercept, right? The x-intercept is getting rid of the y term. So I would just have 7x equals 21, and I would solve this. So by solving this, I end up with x equal to 3. The y-intercept would be the opposite. The y-intercept would be getting rid of the x term and solving for y. So the y would be -3y. You got to be very mindful that negative is still part of that term. -3y equals 21, and then we solve this. And this ends up being y equal to -7. So basically, again, you're throwing out half the equation to solve the part that remains. So if you want to find the x term, you get rid of the y, and you solve the equation 7x equals 21. If you want the y-intercept, then you throw out the x, and you solve the equation -3y equals 21. You get those two values. We've got those two values, and now we're going to graph them, right? X equals 3, and y equals -7. So same thing as before. On the x-axis, go to 3, which will be right here, if you can see that. And then y on y-axis, go down 7 to -7. So 1, 2, 3, 4, 5, 6, 7 would be right there. And then draw a line through them. So something like that. Okay, maybe you could do a little better. You get the idea, right? Good line. All right. Now let's do number 6. So number 6, determine whether the function has a constant or variable rate of change. Number 6, 7, and 8 are basically the same thing. A constant rate of change would be something like a linear function, and a variable rate of change would be something that's non-linear function. So essentially they're kind of asking the same thing. Number 6 is kind of asking the same thing that number 7 and 8 ask. But so here's how you do all these problems. Okay, I recommend using a table. So I would recommend just rewriting this information into a table for number 6. I think that would be easier. So 0, 1, 2, 3, 4, and it was negative 208, negative 205, negative 196, negative 181, and negative 160. Okay. I recommend this because, okay, what we're doing here is we're just going to find the slope. Okay, that's the thing. You need to make sure you understand what we're doing here is we're finding slope, right? We're going to find rate of change. So remember, when we do that, we subtract the y values and then we subtract the x values, right? So the y values go on top, the x values will go on bottom. So when I subtract my y values, what I'm going to be doing, I'm going to take 2 points at a time. So I'm going to take the first two to start with. So I'm going to do negative 205 minus negative 208. So negative 205 minus negative 208. And on the bottom, I'm going to do the x values. So the x values, I'll do 1 minus 0. So I'm doing those 2 points, 1 minus 0. Now what I get from this is the top ends up being a positive 3 and the bottom is 1. So I get 3 over 1. Now keep that in mind as we move forward. All right, try not to erase too much. Okay. The next thing I need you to do is do the next 2 points. So these two. Okay, yes, there's an overlap there, right? Because we did 0, 1 the first time, but now we're going to do 1, 2. Okay, so we're going to use those 2 points, right? So same idea. Take the y terms, right? Subtract them. So negative 196 minus negative 205. So negative 196 minus negative 205. So just subtracting them, and then do the x values next. So 2 minus 1. 2 minus 1. So when we simplify this, this ends up to be negative 196 plus 205, I believe is 9. And then 2 minus 1 is 1. So we get 9 over 1. Now here's a problem, right? This simplifies to 3, right? This simplifies to 9. Now, we've already answered the question. We've already figured out what the answer is. Because a constant rate of change would mean that it's the same number each time. Now, we've already established that these are different numbers. So therefore, it must be a variable rate of change. I don't have to do any more because I've already established that the slopes between these 2 points are different. Since the slopes are different, that means the rate of change is different, meaning variable. Variable means different. So we've already made up our minds that 6 is a variable rate of change, okay? Not a constant one. And essentially, we do the exact same process for number 7 and number 8 as well. So for number 7, let's take the slopes, finding slopes. Let's do these 2 terms first. So let's do the y's. So we'll do 9 minus 7, okay? So 9 minus 7 on the top. And then the x's, we're going to do 4 minus 3. 4 minus 3. Now, when I simplify this, I end up with 9 minus 7, which is 2, and 4 minus 3, which is 1. So this is 2. So keep that in mind, right? That's 2. Let's look at the next one down. So we're going to do 4 and 6 next, right? So 13 minus 9. We're going to do that on top, 13 minus 9. And then we're going to do its corresponding x value. So 6 minus 4 on the bottom. So when I simplify this, I end up with 13 minus 9, which is 4, and 6 minus 4, which is 2. Now this equals 2 when you simplify it, right? So far, so good. We have 2 and we have 2. So right now it looks like it's constant. Looks like it would be linear. But we have one more to check just to be sure. Remember, all of them have to work out, right? So we're going to check the 6 and the 10 next. So remember, we did some overlap. We did the first and second point. Then we did the second and third point. Now we're going to do the third and fourth point. So we're doing those groups together, every pair that we can. All right, so we're going to take the y's, 21 minus 13. So 21 minus 13. And then the corresponding x's. So that'll be 10 minus 6. 10 minus 6. So when I simplify this, 21 minus 13 is 8. And 10 minus 6 is 4. And 8 divided by 4 is 2. So notice all of these were the same. They're all 2, which means it's a linear function. Okay, linear function. And we could also tell this by a different way. Well, not necessarily. We kind of had to do it like this to tell. All right. So we found that, remember, we just did the rate of change, right? Subtracted the y, subtracted the x's, subtracted the y, subtracted the x's, subtracted the y, subtracted the x's, and then we made sure that our answer is simplified as well. So now we got one more problem to do. That's number 8. So number 8, follow the same exact rules. Okay, we're gonna start with the first two, then we're gonna do 2 and 3, and then we're gonna do the third and the fourth one. So we're gonna start here with first, second point. So y is -5 minus 0. So -5 minus 0, and then its corresponding x's on the bottom. 5 minus 2. 5 minus 2. So this ends up to be, let's simplify it. -5 minus 0 would be -5, and 5 minus 2 would be 3. Don't worry about simplifying that. If you want to make it a decimal, you can. In your calculator, this ends up to be -1.6 repeating. So you can do that. That's okay. I don't mind. But let's keep that in mind. Now we have to try the next one, see if it's the same number. So the next set of points, the second point and the third point. So -8 minus -5. So -8 minus -5 over corresponding x's. So 11 minus 5. 11 minus 5. Be very careful again of the negatives in this problem. So we end up with this one. This one ends up being -8 minus -5 ends up to be -3. And 11 minus 5 ends up to be 6. So essentially this ends up being -1/2 or -0.5. Now you can already tell what our answer is going to be because our rate of changes are not the same. They are already different numbers. So there's no reason we need to do the next set of points. You can if you want to, but there's no reason to because we've already confirmed here that we have a different rate of change, meaning that this would be non-linear. So non-linear. So there's our test. Like I said, I recommend you go back and rewatch several parts of this because that's how you study. You know, you have to go back. You have to make sure that you can replicate this on your own. And the only way you can do it on your own is if you study it, you try to remember the steps, remember what to do. Okay? Go back, rewatch those questions as many times as you need to. Okay? Do well on this quiz. It's the last one of the quarter. So please try your very, very best. I will see you guys later. Good luck on your quiz. Bye.